Hi everyone, we are picking up a reaction Claisen condensation from esters. It's a very important reaction in ester chapter. And the reactant for this is ester carrying any alpha hydrogen. What is meaning of alpha hydrogen? It is the hydrogen next to C double bond O of ester group. As you can see in this structure, we have drawn an ester. Look at this thing. And this ester, what will be name of this ester? So name is written first alkyl and alkanoate. So which alkyl? This is alkyl. What is alkyl here? Ethyl. And the other side we have two carbons. So again it is ethanoate. Ethyl ethanoate is the correct name of this alcohol. Okay, if you understand this answer, if I write something like HC double bond O CH3, what could be name of this? Methyl this time because of CH3, and this is one carbon. So methanoate because it is one carbon which is involved in this case, and we call one carbon acid as methanoic acid. Remember that. Okay, so I hope you understand this statement. If it is clear, then we can say reactants are esters with alpha hydrogen presence. Fine. So where is alpha hydrogen here? So if you look at this, can we say this hydrogen which we have with this particular carbon next to C double bond O? Observe this carefully. This hydrogen is carrying This hydrogen carried by the carbon is alpha hydrogen. So what is property of this alpha hydrogen and why we are interested in this alpha hydrogen? So for that, if we can understand, like CH3, C double bond O, OC2H5 is given to us. So we can draw it like this. And whenever you are given any base, C2H5O minus Na plus, can I say this base can come and pick this hydrogen? When the base will come and pick the hydrogen, see what will happen if this will come and pick the hydrogen, this can show enolate kind of answer. So which is CH2 double bond CO minus OC2H5. Now this is a carbon ion which can be attacking from this end where and whenever we require. So where it can go and attack? It can go and attack on any other ester molecule. So let me draw CH3 C double bond O OC2H5, one more mole. So can we say this carbon can go and attack here based on this O bond will break, and what will be the result out of this? It is CH3CO minus. On this position we have OC2H5 and we are further connecting CH2 C double bond O OC2H5. If you observe this thing, what has happened? The unit 1 has combined with another unit 2 of ester and it has given us this kind of product. Now, this is an intermediate. Basically, we should not call it product because still the best is yet to come. So this O minus can remove OC2H5 after slight heating. And the final answer which comes up in this case is CH3 C double bond O, CH2 C double bond O, at this position OC2H5. Can I call it an ester first of all? Yes, we can see C double bond to CH5 is an ester. Okay, what is the next position of this alpha? What is the next position? Beta. And what is the next position? It is gamma. So anyway, we can see beta position, there is some C double bond O. And this is making us write the name beta keto. Keto ester as in, it is a ketone group which is present here at beta position of this. So product becomes beta keto ester. I hope we understand this simple mechanism. Now just come back and see one more point. We have mentioned here that in presence of base. Okay, fine. So what is the base here? This is C2H5O minus Na plus, which is a base and which is giving us the reaction. All right. Now listen, one more thing. We have mentioned avoid transesterification. What is meaning of this term? See, transesterification is basically if you are given CH3C double bond O C2H5, and for example, if I bring C3H7O minus Na plus. Okay, I'm bringing C3H7O minus Na plus. If there is a possibility that C3H7O minus Na plus comes and make it CO minus, CH3CO minus, or we can say this is OC3H7, OC2H5, and forcibly OC2H5 is removed, can we get another ester? It is a different ester, it is not the same ester. So it's a different ester. Can I say it will start its own reaction in this process? and this ester E1 can club with the original ester E2 in different ways, where E1 can club on E1, E2 can club on E2, E1 can club on E2, and E2 can club on E1. So see, their permutation combination will start, and because of this, we will get certain non-required or unwanted products there. We avoid these situations by considering the fact that we should not ensure any kind of trans-esterification. So I hope you understood the word trans-esterification is formation of some esters which are actually not needed at this point of time. So let us revise this reaction once again. Claisen condensation is a reaction of esters with alpha hydrogen which gives us beta keto ester, and we have seen one more example here. Now there is something more into it. If this reaction happens in some, we can say, intramolecular environment, as in, let us draw this thing. So let's say that we call it C double bond O, and this is OC2H5. And similarly, this is, let's say, 1, 2, 3, 4 and 5 member, and this is now double bond OC2H5, and this react in presence of C2H5O minus Na plus. Why do we need the same C2H5 which is written here or written here? Now you know the answer. What's the answer for this? Answer is, it should not be giving any trans-esterification procedure. Okay, so if this is clear, what is the first step in this case? Can I say H will be picked up, minus charge creation. This will go and attack on C double bond O as we normally do in any intramolecular reaction. And we can expect 1, 2, 3, 4, 5 members cyclic structure. Remember, this reaction has a different name. Now when you talk about this reaction, there's a name for it, and it's called Dieckmann reaction. Alright, the name for this is Dieckmann reaction. It is intramolecular Claisen condensation. Its another name is intramolecular Claisen condensation. See the pattern. Now this is the carbon number 1. I'm calling it carbon number 1. Okay, fine. Carbon number 1. Let us say this is carbon number 1. Carbon number 2, 3, 4. 2, 3, 4. Where is carbon number 5? This is carbon number 5. Okay, now see, carbon number 5 will carry 1 O minus, 1 OCH5, and carbon number 1 will carry a bond which carries C double bond O, OC2H5. So what the final and last step, can I say, slide heating, O minus will be removing OCH5 to give us beta keto ester, and this time this ester is a different kind of ester which is C double bond O, OET or OC2H5. Remember, ET is also C2H5. ET ethyl C2H5, Me methyl CH3, PR propyl C3H7, IPR isopropyl branched propyl. So now see this thing. This is the answer here. This is alpha position, this is beta position, and we got the product which is beta keto ester. So actually this particular discussion is about two reactions, now just one reaction. It is about two reactions. One is Claisen and other is intramolecular Claisen. Intramolecular Claisen is Dieckmann reaction. Thank you very much for watching this video. Like, subscribe and share. Thank you so much.